Today we're going to talk about the transformation of functions. Hopefully y'all practice and know your parent functions. If not, we're going to step right into it today on using them. So these are our rules that we use in function notation. What I'm going to do is I'm going to also define f of x so we can follow an equation too. And I'm just going to look at the square root function. So there's two things that are going to be going on here. This would be just the notation, and this one is the equation. Okay, so the first thing we're going to do is we're just going to say that this first transformation, there isn't one. It's just the parent function. So it's defined in notation just as f of x. In our equation, it's the square root of x. Nothing's been done to it. So my first transformation is what happens when I multiply the function by a negative 1 out in front. So what would look like this was what it would look like in the equation. It would look like that. And what this does is reflects across the x-axis. I mean the y-axis. No, the x-axis. Sorry about that. Okay. So it reflects across the x-axis. Okay, so the next transformation is what happens if that negative 1 multiplier is inside multiplying the x. So notice the difference. This is multiplying the y or the whole function. This one is multiplying just inside to the x. So what would that look like in this function? Would be the square root, and I would have a negative x like that. And you might say, well, you can't have a negative underneath the square root, but our numbers could be negative, right? So I could have a negative 1, a negative 2 now, a negative 3, because a negative and a negative would make a positive. And this reflects across the y-axis. Okay. Now we're going to run into some adding and subtracting of numbers to our function. So the first we're going to look at are what happens if I add outside of the parent function, not inside. So something like, I'm just going to put a number on it. So plus 3. This one says plus a, so it doesn't matter what number. And then this would be a vertical shift up 3. Next one would be minus sign, so that's going to be a vertical shift down 3. Next is inside the argument, and this one would be f of x is 2. We'll just stay with 3. And this would be a horizontal translation or shift left 3, opposite sign. So this one would be a horizontal shift right 3. So you might want to star these and realize that these are going to be opposite sign. Anytime something goes on inside the argument, it's not going to do exactly what you think it's going to do. So notice like the other two shifts when it was the 3 was being added outside of the square root. does exactly what you would think it does. Plus 3 shifted vertically up 3, minus 3 went down. But now that we're inside the function on these two and we horizontal, the sign changes. So anytime you're taking information from inside the function, it's not going to do exactly what you think it's going to do. And that's a trend that will go through all these shiftings. Okay, so now what happens if I have a multiplier outside the function? This would be, so not a negative, just a number besides -1. This would be a vertical stretch by a factor, or by a multiplier, right? A factor 3. Now again, now we're about to take information inside, so it's not going to do exactly what we want it to do. So now the 3 is going to be inside. So it's not going to just be a 3 multiplier. It is going to be a vertical sorry, a horizontal compress by a factor of 1 over a. And this one of 3, or really we should have said a, right? For the other example, we'll say for this example, it would have been 1/3. So notice anytime I take that information inside the argument or inside the function, it doesn't do exactly. I see a 3 there, but I'm taking the information out, so it's a third. Okay. The next one I have 1 over a, so this would be f of x equal to 1/3, and this would be a vertical compress by a factor of 1 over a, or in our other example, or 1/3. So notice it's outside of the function, it's multiplying outside, not inside of it, and it does exactly what it's supposed to. Next example, we'll say f of x is equal to 1/3 x. So this one is going to be a horizontal stretch by a factor of 3. So I've taken the reciprocal when it's a multiplier inside, and I guess I want to say a here first, and then for this example, it would be 3. Okay, so I'm just going to star a couple of these that we know don't do exactly what they're supposed to, and there's 4 of them, right? And notice it's always something happen inside of the function. Okay, so I'm going to keep going, and we're going to do a couple more examples. I have another INB that just has examples, your homework, and you're just going to look at a couple of these functions, and we're going to shift them. These two INBs would be in the same page right next to each other, so you could look at the rules and look at these examples side by side. So the first thing I'm going to do is I'm going to realize this is the square root function. And I know that I'm being subtracted 2 outside of the function, so my variable description, I'm okay with just writing down 2. And this is what helps knowing our parent functions already. I have 3 key points, which were 0, 0, 1, 1, and the square root of 4 is 2. Okay, so this was square root of x. Now what I want to do is move everything down 2. So down 2, down 2, down 2, and this is the square root of x minus 2. Next one is a quadratic. Quadratic. and that would be x squared. This would be square root of x. And it's being multiplied by a negative outside. If it was inside, there would be parentheses. So this is a x-axis reflection. So again, my three parent function points. That's why it's important that we know those points. And then I'm going to reflect them across the x-axis. Here is negative x squared, and this one is just good old x squared. Okay, next is my absolute value function. And my verbal description, this is having a 1/3 multiplied inside. Remember, I'm going to take that 1/3 information out so it doesn't behave exactly as you see it. So this is a 1, since it's a multiplier, it's going to be the reciprocal. So the reciprocal of 1/3 is 3. So now I know it's stretched. I'm multiplying it by 3. That's going to make it a greater number or stretch it. So this is a horizontal stretch by 3. Okay, so I'm going to get my 3 parent function points. And since it is a horizontal, that is my x value, and I'm going to multiply my x values by 3. So my x value is at 1 at this point right here. So 1 times 3 is 3. So it moves out here. And the same thing with my negative 1 multiplied by 3 is a negative 3. My y stayed the same. And if I multiply 0 by 0, and then here's my horizontal stretch. Okay. My next is number 4, is going to be a exponential. Just due to the x, it has an asymptote. Y equals 0. Got that 1/2, 0, and 1, 2. Looks like this. And now I notice the only thing that has changed is I have a multiplier. This time it's my x value. So this is a y-axis reflection. So I'm going to take my points and reflect them across the y. So here's this point, and it's going to reflect across the y right on the other side. This is on the reflection line, so it stays. This point over here is going to reflect over to the other side. And there we go. Mirrored across the y-axis. So this is 2 to the negative x, and this one's 2x. Okay, my next one is I have a half multiplier to the log function. And I remember my log is the inverse or flip-flop of the exponential. So it has an asymptote at x equals 0. And I remember it had the point 1/2, -1. And then it had the point, well, instead of 0, 1, it had it at 1, 0. Instead of 1, 2, it's at 2, 1. So this is my log base 2 of x function. And what is happening, I forgot my verbal description. This half is multiplying outside of the function, so we take it for exactly it is. So if I'm taking half of the values, half of the y values, that would be a compress. So this would be a vertical compress. Half. So I'm going to go to all my y values and I'm going to cut them in half. So this y value right here was at 1. Half of 1 is a half. This y value is at 0, so it stays. This y value is at -1, so it goes to -1/2. And it kind of looks like this. This is my log, a 1/2 log base 2x. Next is my step function. So my step function looks like, remember the key point 0, 0, 1, 1, -1, -1, and it has these. So there we go. And this one is going to, well, it's the -3 is inside the function, so it doesn't do exactly what it's supposed to. So instead of saying it's going to go left 3, it really goes right. So I'm going to shift all those points right 3. 1, 2, 3. Opens. 1, 2, 3. Follow my solid dot. And 1, 2, 3. And there's my step function shifted right 3 units. Okay, 3 more. These are multiple transformations, so I think all of these have 2 transformations. The last one has 3. So this is my square root function. Change that color back to be consistent. And this one is being 1 vertical stretched. You have to go from left to right on these transformations when there's multiple. So the left is 2, vertical stretch by 2, and left 3. So 0, 0, 1, 1, 4, 2. And I'm thinking, did I do that? 1, 4, 2. I think last time I only went 1, 2, went over 3. Should have been 4. Okay. So here we go. And now I'm going to do my vertical stretch of 2. So all my y's get multiplied by 2. I'm going to do this all at once, by the way, too. So I'm going to go, this one stays the same. And then I'm going to go left 3. 1, 2, 3. Vertical stretch of 2. So I was at 1. So 1 times 2 is up to 2. And then left 3. 1, 2, 3. And this one was at the height of 2. And I'm going to stretch it by 2. So I'm going to multiply it by 2. So I go up to 4 and then left 3. 1, 2, 3. And here's my function. These will be difficult at first, but we'll practice enough in class. We'll save time definitely to practice a lot of in-class practice when we're in class. Next one is I have a x-axis reflection. And I got that half, but this time the half is inside. So I've got to take the reciprocal. So it's going to be a horizontal stretch by 2 by a factor, by a multiple of 2. So I have the quadratic. Here's the parent function. And then I want to reflect. And then I want to multiply by 2. So I'm going to do those 2 different things. So I'm going to start with the leftmost point at -1, 1. And I'm going to reflect it. And then I'm going to multiply my x value by 2. I'm at -1. -1 times 2 is -2. 0, 0. I reflect that. I stay at 0, 0. Multiply my x by 2. So it stays right there. And then this point, I'm going to reflect down. And I'm going to multiply my x by 2. So 1 times 2 is 2. And so it's reflected. and horizontally stretched. So if you think about it being pulled from left to right, it kind of gets wider. Okay, next one I have 3. I have the absolute value function. Go ahead and graph that V real quick. And my first thing is a vertical stretch. Notice I'm going left to right. You have to, otherwise you get the wrong transformation. Vertical stretch by 3, a multiplier of 3. 2 is right 1, 3, up 2. So here I go. I'm going to multiply my y's by 3. So 1 times 3 is 3. So these all move up here. And then I'm going to go right 1, up 2. So right 1, up 2. Right 1, up 2. And I'm going to also take my 0, 0, go right 1, up 2. And here is my function. Notice it got vertically stretched, so pulled up, so it's a little bit skinnier. And there's my function. So hopefully this will help. We do have some homework. It could be difficult to get started, but once we get into class, we'll spend time. I'll walk around. Thanks. Have a good night.